Hello and welcome to YourPedia. My name is Aman Sharma and I'm your mentor for CSC at YourPedia. So in this video is regarding the questions series that we have started. So 1,000 questions we are going to try because NIC exam is coming on 4th of October, 4th of November, sorry. So we are going to do questions of different subjects regular basis. So we'll be taking each subject and then we will be starting to try to solve those questions. And in order to do that, we have prepared a PPT for you. So we have selected some questions. Today we are going with theory of computation and compiler. Now this is the schedule for all the sessions. So on 4th we have theory of computation. After that on 7th we have algorithms plus data structures. Then for DBMS 8th, operating system on 11th, digital on 12th, CL on 13th, Go on 15th, computer CS on 18, discrete maths on 20, aptitude 23, analog 25, aptitude 27, software engineering 28, aptitude 30. We have kept multiple sessions for aptitude because aptitude is very important in this exam. So 42 questions will be coming from aptitude out of 128. So only 78 technical questions and 42 will be aptitude based questions. So you have to focus on aptitude also. After that, miscellaneous topics such as cloud, IoT, cyber security will be done on 31st, and again, then the final session will be of aptitude before 2 or 3 days before your exam. So you will be able to prepare these topics. Now we have also launched a book for NIC. In this, we have covered 2,500 questions related to all the subjects that we have mentioned above. So you can solve these questions because there is only 1 month left. So you must have completed your syllabus, and after that what will affect your score the most is the number of questions you try before giving the exam. Because if you are making mistakes right now, you will be correcting those mistakes and you will be not doing those mistakes in the exam. So try as much as questions as possible. So we have selected questions from various exams such as ISRO, NIC, and your GATE or your UGC. So this book will have 2,500 questions in which we will be also providing you the solution for these questions. Now after that, we have also started a test series for NIC also. So for NIC, we have started a test series in which you will get a test for each subject. So for each subject, you will get multiple tests, and you will also get the mock test in which the exam pattern will be followed completely. You will be given 3 hours for 128 questions, and the exam level will be par NIC. So you will get how what type of questions you will be expecting in the exam, and how much time you require to solve each of the question, or which areas where you are lacking you can improve on those areas, because this 1 month is very important for you. So good evening, Tejasvi, Suresh. So now we'll start the session. So we'll solve 50 questions from theory of computation. Yes. So first is complement of NFA can be obtained by any answer. So complement of NFA of DFA can be obtained by one method only. You have to change the final states to non-final states and non-final states to final states. So how we can do that? Let's say that you have a DFA. You have to make a DFA for no consecutive zeros. Now for no consecutive zeros, it is difficult to make NFA, or you can, as the exam will have very less number of time, so you have to solve these questions very quickly. So no consecutive zeros means you can solve this by making a DFA for consecutive zeros, complement. Now how to make a DFA for consecutive zeros? So, or you can say substring of it contains substring of 0. So whenever two zeros come, after that you don't need to worry about anything. Anything can come after that. So 0, 1. So 1 will not affect our answer. Now in this, if you change the states of non-final states to final states and final states to non-final states, then you will get. So if you change non-final to final and final to non-final, you will get a DFA for no two consecutive zeros in this. So this is how you take complement of a DFA. So making final states non-final and non-final as final will be your answer for this. Now next is any doubts in this? Okay, no doubt. So next is, which of the following statements are true? First of all, Mealy and Murray machine are language acceptors. No, Mealy and Murray are language translators. You put a string into the Mealy and Murray machine, then you will get a string as an output. So these are not true. Finite state automata is a language translator. No, it is a language acceptor. You put a string, it will tell you whether that string belongs to the machine or the language for which the machine has been designed. So finite automata is an acceptor, Mealy and Murray is a translator. NPDA is more powerful than DPDA. This is correct, because if you see the order, finite automata is less powerful than PDA. Now PDA have two different type of machines, DPDA and NPDA. So in this, NPDA is greater than, will have more power than DPDA, because it is used for CFL and it is used for DCFL language. So this is correct. Mealy Murray is more powerful than Murray machine. No, you can convert Mealy machine to Murray machine. You can convert Murray machine to Mealy machine. They have equal power for. Both have equal power. So someone is saying that TOC is not in syllabus for NIC. No, if you see past year questions of NIC, they in the syllabus they have mentioned compiler, but if you see the past year syllabus also and past year questions also, and theory of competition was not mentioned, but they still ask questions from theory of competition, because compiler is directly linked to theory of competition. Next is third question is, finite automata accepts which type of language? Now it is three options are type 0, type 1, type 2 and type 3. Now if you see the languages, so if you take type 0 grammar is a non-restrictive grammar. Anything can come in between in it. So it is used for languages such as RE, and the machines used are Turing machine. If you increase the restriction in type 0, then let's say that restriction is for any production A to B, if you apply the rule that length of A should be less than equal to length of B, then it becomes type 1. Now in type 1, we require linear bound automata, and the language is CFL. After that, if you increase the increase the restriction, and the restriction is that A length of A should be equal to 1, then it is a type 2 grammar. CFL comes under it and PDA is used. And if you again increase the restriction that only right linear should be there or left linear grammar should be there, then it is a type regular language, which is also called type 3 grammar. So regular language use type 3 grammar. Next is what this represents. So you have been given a regular expression, you have to tell which of the strings will come into it. So 0 concatenated with 1 will give you 0, 1. 0 concatenated with epsilon will give you 0. 1 concatenated with epsilon will give you 1, and epsilon concatenation epsilon will give you epsilon. So 0, 1 epsilon and 0, 1. So the correct option for this will be option number A. Everyone who is saying that TOC is not in syllabus, you can see the past subjects and past exam paper NIC, and you can also see the past year syllabuses. TOC was not mentioned there also, and but the questions from TOC has been asked, and as compiler is given, compiler is directly linked to TOC. So TOC is very important because two subjects are linked to it. Next is, what is the relation between NFA and DFA? Now you can, as you know, there are algorithms to convert DFA to NFA and NFA to DFA. So if NFA to DFA can be converted into each other, this means what? That they have equal power. So NFA to DFA has equal power. NFA is equally powerful as DFA. Next is, finite automata require minimum dash number of stacks. Any idea? Any idea for this one? So finite automata. Now finite automata has finite memory and has zero stacks. Zero stacks. If you add one stack to finite automata, if you add one stack to finite automata, it will behave like PDA. If you add two stacks to finite automata, two independent stacks, it will behave like linear bound automata. And if you add an infinite tape to finite automata, it will behave like Turing machine. So the correct option will be minimum zero number of stacks are present in the finite automata. Next is, which of the following definition generate the same language as L, where L is equal to x raised to power n, y raised to power n, and number of x is equal to number of n. You can see minimum string is xy, next minimum, the second string is xxyy, then we will have triple x and triple y, and so on. So this is the type of language, and these are the strings made by this language. Number of x will be equal to number of y. First is grammar. E, from here you are going to x ey, and also you can go to ey. So if you use this production x to xy, then you will get the first string. If you want to make 2x, just take exy production, and this e will further go to x and y, and then you will be able to make equal number of x and equal number of y, where y will follow x. So this is correct. Second is xy, such that x plus xy, y plus. So in this, minimum string is first of all xxyy, because x plus takes one value at least. After that, plus x plus and y plus, they can have different type number of x's and y's. So it can have x and y and then 3y. So it will not have equal number of x and equal number of y. Similarly with this one, again not equal number of x and not equal number of y. So the language, only one will be the option. Now next is, the regular languages are closed under which set? Now regular languages are closed under everything. If you take union, if you take concatenation, if you take clean closure, if you take union, intersection, your complement, your clean closure, your concatenation, or your homomorphism, inverse homomorphism, you take any of these functions, or you can take reversal. Regular languages are closed under all of these. So the correct option will be all of the above, option D. Next is, any string of terminals that can be generated by following CFG. So what this language is? So this question came in NIC in previous year question paper. So it is a NIC question that was asked previously in the exam. So S of xy, x goes to here, y goes to here. First we will see what x is making. So x is making any number of a's and any number of b's, and then it will end with a. You can make any number of a's by using xa, and you can make any number of b's by making x dx, and you can also mix and match xa, xb, or you can make ab or ba, anything like that. So x is making a plus b star a. and y is making, so it will start with a, at the end it will have a plus b star, because this y will be in the end will be changed to this a by using this production. So it will be a plus b star. So if you use x is equal to xy, this will give you a plus b star, a, one more a, and again a plus b star. So the options are has at least one b. No, a is the minimum string that will be made, so at least one b will be false. A should end in a. So this is not true. It can end in b also, because we have a plus b star at the end. Has no consecutive a's or b's. No, in the regular expression also you are having two consecutive a's. So again this is also false. Has at least two a's. Now at least two a's. If you see this, if you take this string, it is having at least two a's, but this string is not part of this, because you need to have two a's as a substring. So the question that was asked in the NIC, it was a wrong question. So all the options were incorrect for this one. So the correct option will be, or correct answer will be, that it is having substring AA in between. Now next is context-free grammar can be recognized by. So context-free grammar can be recognized by. Now we have seen previously also when we were doing type 0, type 1, type 2, type 3. For regular language, you need finite automata. For CFN, you need PDA. For CSN, you need linear bound automata, and for recursive enumerable, you need Turing machine. So context-free grammar can be recognized by not finite automata. Now, if a linear bound automata, if so let's say a PDA is able to do CFN, so linear bound automata is a powerful machine, more powerful machine than PDA. So if PDA is able to accept it, linear bound automata will also be able to accept it. And next is push down automata. So the correct option will be both B and C. Next is language. W raised to power A, X raised to power B, Y raised to power AB is what? Regular, context free but not regular, context sensitive but not context free, type 0 but not context sensitive. Now if you see in this, first you have to have some number of W's, let's say W raised to power A, then you have X raised to power B, and whatever the total number of W's and total number of X, it should be equal to the total number of Y. So the string will look like WXX, and then we will have triple Y. So there is a comparison. You need to add these and you have to compare it with number of Y. Whenever there is one comparison, what we do? We need one stack. How? For let's say W, let's say for W, we are pushing 1 into the stack. Let's say the string is WXX triple Y. So the command will be for W, push 1, for X, push 1, for Y we will pop 1. So whenever a W comes, we will push 1 into the stack. For X, 1 into the stack. For other X, we will again push 1 into the stack. For the first Y, we will pop 1. For second Y, we will pop 1. For third Y, we will pop 1. So what will happen when the stack gets empty and string is completed? This string will be accepted because it is part of this language. So this language needs one stack in order to make the comparison, as there is one comparison in it. This means this is a context-free language but not regular, because finite automata will not be able to do this. Any doubts till now? Okay, then let's move on to the next question. Now next is, In the given language, this number of strings in L star are. Which of the following will be part of L star? So you have to concatenate these strings in order to make concatenate these strings by using these symbols so that they will be in L star. So if you see this, you will have BAA, then by A you will have in B, and then for this BA you don't have symbol. So this will not be in our language L star. Then we can use AA for this one, BAA for this one, and again AA for this one. So this will be in the L star language. Again BAA, 1A we are using, then again BAA, again 2A we are using, then again BA. So this will also be in our language. Then BAA, again 1A, BAA, and again 1A. So 2, 3, 4 will be our answer. B, C, D will be our answer for this question. Next is context free grammar. S is equal to ASB, DSA, and epsilon generates what? Now you can see from S, first of all you can make epsilon. Pretty simple production. After that, whenever you make A, you are making a B with it, and whenever you are making a B, you are making a A with it. So if you see the pattern, you can see that it is having equal number of A's and equal number of B's in this language. Now the next is #15th question. 15th is, according to given language, which of the following expressions does it corresponds to? So language is that x is length of 4 or less. So the x can have length 0, x can have length 1, x can have length 2, and x can have length 3 and 4. Here you can see 0, 1, 0, 1, 0, 1. You can write it as 0 plus 1 raised to power 4. So it will be giving you length 4. It cannot give you length 3. Again length 4. This will be giving you 0, 1, 0, 1, 0, 1, 0, 1. 8 length. Again false. This is option D is true, because let's say 4 times you have to write this. So 0 plus 1 plus epsilon into 0 plus 1 plus epsilon, and 2 more times 0 plus 1 plus epsilon and 0 plus 1 plus epsilon. Now whenever you want to make a 0 length string, you will take epsilon from this, epsilon from this, epsilon from this, and epsilon from this. Whenever you want to make a string of length 3, take epsilon from this, 0 or 1 from this, 0 or 1 from this, 0 or 1 from this. Whenever you make a length, this is length 3. For length 1, epsilon, 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 and 0 or 1, anything you can take. For length 2, take these two as epsilon and these two as 0, 1 and 0, 1. And for 4, everyone you will take 0, 1, 0, 1, 0, 1. So it is a shortcut way of writing length 0 or the up to length 4, which will include 0, 1, 2, 3 and 4. Now next is, what is the meaning of regular expression this? So you have 0 plus 1 star, 0 plus 1 star at the end, 0 plus 1 star at the end, 0, 0, 1. So what will be the answer for this? Containing a substring 0, 0, 0, 1. So option D will be correct answer, as it will be having 0, 0, 1 as the minimum string. After that anything can come, and before that anything can come. So it will be having 0, 0, 1 as its substring. Now next is #17. Which of the following is a correct hierarchical relationship of following? So L1 is a set of languages accepted by NFA, DFA, DPD, NPD, recursive and recursive enumerable languages. So if you have studied this, you know that DFA is equivalent to NFA. They both are having equal power. So any number of languages accepted by DFA will be accepted by NFA also. So L1 will be equal to L2. Now DPD is more powerful than finite automata. So it will be accepting languages which are DCFL and also accepting languages which are also regular. So it will be a bigger subset than L1 and L2. Similarly, NPA will also accept CFL and DCFL and finite automata. Again, for the set of recursive languages will be accepted by Turing machines, halting Turing machines actually. And then last is recursive enumerable, which is RE language. So the correct option will be option A for this one. L1 equal to L2, and the L3, L4, L5, L6 will be increasing in the number of languages present in them. Yes, correct, SSJ. Next is L1 is CFL. Next is L1 is CFL, L2 is regular language. Which of them is false? First is L1 minus L2 is context free. Now this is a property. If you take any language and take its difference with R, R is a regular language, it is closed. So this means that language will be L only. So if you take CFL minus regular language, it will be a context-free language. So it is not a context-free language, so this is a false. So they are asking which of the statements are false. So A option is false. L1 intersection L2 is context-free. Again, L, any language L intersection with R is a closed property. Regular language, if you take any intersection with the regular language of any language, it is closed. So this means that language will be that language only. So L1 intersection L2. So L1 is CFL intersection regular will be CFL only. So this is correct. L1 bar is context free. Now context free is not closed under your complement. So if L1 is context free and you take your complement of context free, it is not closed. So you have to pump it up. When you pump it up, you get CSL, and if you take the complement of CSL, CSL is closed under complement, so that language will be CSL. So again, C is also false. So both A and C are false. So the correct option will be option D. Next is 19th. Consider the following type of languages. Which of the following are true? L1 is regular, contextually recursive, and recursive enumerable languages. If you take first one, L3 bar union L4. So L3 is what? Recursive languages, REC. Union L4 is RE. Now REC are closed under complement, so you will get REC, and in order to compare these, to apply closure properties, you have to pump it up again. RE union RE. So RE union RE will be what? RE is closed under union, so this means this language will be RE only, recursive enumerable. So first is correct. Second is L2 union L3 is recursive. Now L2 is context free. Union recursive is REC. You cannot compare these because these are not same languages. So every CFL, using Chomsky hierarchy, we can say every CFL is a CSL. So again, it is not equal. Again, we will pump it up. So we will take it to REC. REC union, we know that is closed. So this means this language will also be recursive language. Third is L1 star union L2. L1 is regular. Regular is closed under your clean closure. So regular star will be regular only. Union CSL. Any language, if you do its union, its subtraction, and its intersection with regular language, it is closed. So this means this language will be again CFL. So third is also correct. Next is L1 union L2 bar is context free. Now if you take L1 union L2 bar, so regular union CFL bar. Now CFL is not closed under complement. If CFL is not closed under complement, we have to pump it up, and if we pump it up, we will get CSL. Now CSL is closed under complement. When CSL is closed under complement, it will give you CSL only. So regular union CSL, and if you take union of CSL with regular language, it is closed. So this means regular union CSL you will get answer as CSL. So it is saying context free, but we are getting CSL. Now what is the meaning of your this closure property? This, if any language, if any property is closed, now it is saying that answer is CSL. So this means surely CSL, our language will be CSL. but there will be cases when it will be context free also. But we are talking in general terms. So general terms we are using just closure properties and a language which is CSL. You are not sure, you will not be sure that whether it will be context free or not, because if it is a CSL, it will be accepted by linear bound automata. What is the guarantee that it will be accepted by a machine which is less powerful, which is PDA? By this same machine it will not be accepted. You are not sure, so it will be this statement is false, that it is context free. It can be, it cannot be, it may be, but sure answer is CSL. So the correct option will be all these three options will be correct, and the last option will be false. Next is 20th question. Let L belongs to sigma star. So this means L belongs to A plus B star. Yes, sigma is A plus B. Which of the following is true? First is L1. First is language X such that X has equal number of A's and B's is regular. Now, if you have to compare number of A's and B's, now there are infinite strings in sigma star. So this means you have to make so many comparisons, and in order to make, let's say you have to compare A and B, you need some memory. But finite automata has finite memory, so it will not be able to do the comparison. If there is one comparison in between in your language, then finite automata will never be able to do it, because finite automata cannot make infinite comparisons. So this means this is false. Again, A raised to power n, B raised to power n. This is also you have to compare number of A's with number of B's. One comparison is there. Again, not regular. Has more A's than more B's. Again, comparison needs to be done. Is regular. Again, not true. AM raised to power Bn is regular. Now you see, any number of A's can come, then any number of B's can come. Both M and N should be greater than equal to 1, but there is no relation between them that M should be equal to N or M should not be equal to N. So any number of A's, any number of B's. Simply what you can do, you will make a finite automata with A here, then A, I am making a NFA, then B, and then again B, it will be accepted. So DFA is possible for this one. So D option is a regular language. Next is consider the following automata. Consider the following automata. So the automata is, I will draw the automata here so that it is more clearly visible. So we have, for A, if the symbol is Z0, we are pushing into the stack. If A comes, symbol is A, again we are pushing it into the stack. Whenever B comes, we are pushing it into the stack. After that, no matter what, how many B comes, we are again pushing B into the stack. After that, what we are doing, for C, we are popping B. Then after that, all the C's will pop D, and all the D's will pop A, and then after that it will be accepted. So what it is doing is, A comes, after that B continues to be pushed into the stack, then C will be popped, and it will pop, when C comes, what will be popped into the system? B will be popped out of the system. So C is popping B and D is popping A. So what this language is, A raised to power, let's say M, and B raised to power N. So B should be equal to number of C's, and number of D's should be equal to number of A. So this is the language that is being accepted by this push down automata. So the strings accepted, not accepted are here number of 2 A's, 2 D's, 3 B's, 3 C's. This is accepted. 2 A's, 2 D's, 2 B's, 2 C's. Again accepted. 2 A's, 3 D's. And these are not similar. Number of A's are not equal to number of B's. So this string will not be accepted by this PDA. After that, again AD, 2 B's and 2 C's. Again, this will also be accepted. Now next is, given as NFA with 4 states, minimized equivalent minimized DFA has at most how many states? Now what is the relation between NFA and DFA? If any NFA is having n states, then this means DFA will be having at max 2 raised to power n states. Where you can from where you can get this relation is, let's say you have any state, you have two states A and B in DFA, A and B, and the input symbols are small a and small b. Now, if you take input symbol A on state A, in NFA there is an option that you will not go anywhere. There is an option that you will go to state A. There is an option you will go to state B, and there is an option that you will go to both state and both state A and B. So for two states, four options are there. Similarly, for three states, there will be 2 raised to power 3, which is 8 options. So for n states, maximum number of possible DFA states will be 16. Now, next is maximum and minimum number of states. Now, let's say your NFA has 10 states. Now, if your NFA has 10 states, but it does not have a single finite final state, so it will not be accepting any language. So for that NFA, the DFA will be simply this without any final state. So minimum number of states for any number of NFA is 1, and maximum is, we have seen, 2 raised to power, and so the correct option will be option C. Now let's move on to the next question. 24. Consider the following languages. How many of the languages are regular? Now it is a pretty easy question because we have done this kind of question previously also. So a raised to power n, b raised to power m, where n is equal to m. Comparison is there. No, not regular language. N is not equal to m. Again comparison, not regular language. A raised to power n, b raised to power m. Yes, no comparison because both n and m needs to be greater than 0, but there is nothing mentioned about whether they needs to be equal or greater or not equal to each other. So no comparison, just the DFA we have seen previously. Next, again, a raised to power n, b raised to power m, again same language it is. So two languages are regular here. Next is consider the following languages: a star, b star, and a raised to power n, b raised to power m, and it is saying that L1 dot L2 will be. Now, if you see a star, b star, any number of a's and any number of b's, after that, a raised to power n, b raised to power n, where n and m both are greater than equal to 0. This is also a star, b star. So if you do concatenation of this, you will get a star, b star, and again a star, b star. So the correct option will be option B. Next is question number 26. Consider the following statements. Consider the following statements. That first is Turing decidable languages. First is Turing decidable languages here are closed under complement and intersection. So Turing decidable languages. What are Turing decidable languages? Now, if you see a Turing machine, if you put a RE languages in it, so if the language is part of a Turing machine, if it is a part, if a string, you put a string into a Turing machine and it is a part of Turing machine, it will tell you yes. If you put a string which is not part of the Turing machine, it can tell you no, or it can go into the infinite loop. So this is the halting problem with your RE languages. So Turing recognizable languages are RE languages, and Turing decidable languages, which surely gives you the answer whether the string is part of the your language or not. For yes, it will give you an accurate answer. For no, it will also give you an accurate answer. So Turing decidable machines are languages are what? REC languages, and Turing recognizable are RE. Now this question is simple. It is just based on the closure properties of your closure properties. So Turing decidable languages REC are closed under complement and intersection. True. Turing recognizable are closed under complement but not under intersection. This is false because Turing recognizable RE are not closed under your complement, but these are closed under intersection. So Turing decidable and recognizable are closed under union, yes, and intersection. So A statement is true and C statement is true. So the correct answer will be option A, which is 2. Any doubts till now? I'll be waiting for 10 to 20 seconds. If you have any doubts, you can put it, then we'll try to solve it. Next is consider a following grammar. What is the language accepted by this grammar? S to AS, B to BS, and then S to A/B. Are you able to understand the concepts, and are you able to understand the questions that we are doing here? Yes or no? Okay. So S is equal to AS and BS, and S will end at AB. Now you can see by using this production, you can make any number of A's and any number of B's, and also what you can do, the order will not matter. First A can come, then B can come, or first B can come, then A can come, then 3 A's can come, then 4 B's can come, anything can come, because you can make anything. AS, after A I want to make B, after A again I want to make B, again I want to make A. I can make any number of A's, any number of B's, and at the end, whatever the S is, it will end with A or B. So at the end, we will have A plus B here. So here at the starting, we have any number of A's and any number of B's. So A plus B star. And at the end, we will have one A plus B to terminate our grammar. So A plus B star into A plus B is nothing but A plus B plus. So the correct option will be option B. Next is let sigma be a finite non-empty alphabet and 2 raised to power sigma star is the power set of sigma star. Then what is it? Now, first thing, if sigma is, let's say, A comma B, sigma star is nothing but strings of all length. So it is a superset. It is nothing but A plus B star. It is a superset of all languages, and we know that this thing is countable. First of all, sigma star is countable. It is infinite, but it is countably infinite. Now there is a theorem, Cantor's theorem. So in what Cantor's theorem say that if you have a set S which is countable, then 2 raised to power S will be uncountable. The power set of a countable set will be uncountable. So sigma star is countable, 2 raised to power sigma star is uncountable. So the correct option will be option C. Understood? So this theorem is called Cantor's theorem. Next is minimum number of states required for A star B star is. Now A star B star. Now A star B star, if I make a simple NFA for it, the simple NFA for A star B star will be A. Then we will have epsilon move. Then we will have B star. Now DFA cannot have epsilon move. So minimum number of states only we can find. We normally find in DFA what is the minimum number of states, because minimum DFA is the unique DFA. So what we can do with A star B star is I can try to rewrite A star and B star as epsilon. I can write epsilon plus BB star. So BB star will give you B, 1B, 2B, 3B, and epsilon will give you 0B. So it is again B star. So if I multiply this, we will get A star plus A star BB star. Now for this NFA is easy. For A star, the NFA will be, for A star, then we are having B, then we are having B star. And as there are two regular expressions, it is sum of two regular expressions, A star and A star BB star. So for A star, final state will be this. For A star B star, final state will be A star BB star, final state will be this. Now this is the NFA, which is a dead NFA. For this state you have A and B, for this state you only have B. So for dead NFA, if I add a trap state to it, which is A, I will get a DFA, and this is a minimum DFA for this one. So the minimum number of states in this will be 3. So 3 will be the answer. Option A will be the answer. Now next is let L1 is equal to CFL, L2 is equal to CFL, and L3 is regular. What is L1 union L2 intersection L3? So if I do CFL union CFL and then their intersection with regular. Now CFL is closed under union. We know that CFL is closed under union. So this CFL union CFL will also give you CFL. And again using that property, if you take intersection of any language with regular language, it will give you the same language because those are closed. So this means the answer will be CFL. So the correct option will be option B. Now, if it is a multiple choice option, so CFL, if a language is CFL, it will also be CSL. If a language is CSL, it will also be RE. So if it is a multiple choice option, all three will be correct. If it is a single answer option, then CFL will be correct because CFL is the stronger answer. You are giving more accurate answer in case of CFL. The number of steps required to generate a string of length 4 using CNF is. Now, what is a CNF? Chomsky normal form. Chomsky normal form states that any variable should go to two variables or it should go to a single terminal. Now, let's take a grammar. Let's say S is equal to AB. A goes to, let's say, CD, and B goes to EF, and C goes to smaller c, D goes to smaller d, E goes to smaller e, F goes to smaller f. Now, if I want to make a language, a string C, D, E, F, what will be the tree? The tree will be S goes to AB, and A goes to EF, and this B goes to, sorry, this goes to CD, and this goes to EF, and then these will go to C, D, E, and F. Now you can see here, if you take this production, if you take one production, your symbol will go from 1 to 2. If you take one more production for this, your variable, the capital symbol for the variable will go from 2 to 3. If you take another element, it will go from 3 variables to 4 variables. But each variable is converted here. So in order to get a string of, let's say, n, so for n terminals, you need n variables. So for, in this case, 4 terminals were there. In order to create these 4 terminals, we required 4 variables. So 4 productions were required here. Now, each production, when you are talking about variables only, each production will increase the variable by 1. Now, for this one, first production is this, second is this, third is this. 3 productions required for 4 variables. For 2 productions, how many? For 2 variables, how many productions required? 1 production. For 3 variables, how many productions required? 2 productions. 1 this, second this. And for 4 variables, how many productions required? 3 productions. So for n variables, n minus 1 productions will be required. And then in order to convert those n variables to n terminals, n more productions will be required here. So answer will always be 2n minus 1. So for length of string 4, 2 into 4 minus 1, which is equal to 7. So this is the formula for CNF, and this is how we get this formula. We generalize this and then we get the formula. Next is language A raised to power n, B raised to power n, C raised to power m plus n. Again, number of A's plus number of B's should be equal to number of C's. So you will take a stack, you will push all the A's, you will push all the B's, and if at the end you have 3 C's, so first C will pop this, second C will pop this, third C will pop this. So you need one stack in order to make this comparison. So this means it is a CFL and it cannot be regular because it cannot be done by finite automata, as we require one stack and finite automata has 0 stacks in it. Next is, consider the following language A star, and it is saying then L bar, there is a, so it is saying that L bar union L star and sigma star minus L will be equal to what? Union. So L bar, if you are taking a symbol A star, a symbol, only one symbol A, and L bar will be equal to, so A star is having epsilon A, double A, triple A, 4A, 5A, and so on. So L bar will be having complement of A star, which will be 5, because A star is having every string in it. Union L star, so A star star, A star star is nothing but A star only, and A star union phi is A star. So you get A star from this side. Union sigma star minus L, you are taking a full superset of language minus L. So full superset of language on symbol A will be A star, and if you subtract A star from it, you will again get 5. This is nothing but complement of L. If you subtract any language from the superset or from the universal set, you will get what? You will get the complement of that language, and again if you do this union, you will get A star. So correct option will be option D. Now next is question number 34. The number of tokens in this string is, now whenever you count the tokens, you give the numbering. So print F, this is the first token, this bracket will be second token. After that, whenever there are comma, inverted commas, so it will start the string from inverted comma, and it will go till the when the inverted commas close, and it will take this as 1 token. So 3, 4, fifth is I, and is 6th, then 7, then 8, and then 9. So total 9 your tokens will be there in this string. After that, again identify, again printf is 1, this is 2, again this comma is 3, then 4, then 5, then 6, then 7, then 8. So again in this, how many tokens? 8 tokens are there. Next is, which of the following statements are true about parsers? So we have to compare the powers of parsers. So what are the powers of parsers? LR0 is the weakest, then after that SLR is more stronger, because when you make the table for LR and SLR is having more your error entries, because whenever you fill the reduction entries in SR, you only fill in the follow. So when you only fill in the follow, the blank entries will be more in SLR, and more the blank entries, more it will give the answer faster than the LR. So SLR is more powerful than LR, then LALR is powerful, and then we have CLR is most powerful. So first is canonical LR, which is CLR is more powerful than SLR, which is true. SLR is more powerful than LAR. No, SLR is more powerful than LALR. Sorry, again CLR is also not true. So only one is true, which is option A. So yes, correct. Next is, consider the following syntax directed scheme SDTS with non-terminal S and A and terminals A and B. This is the string, and it is saying that what will be the output printed if the input is AAB. So by using this, we will make, by using this grammar, we will make a tree of SSB, and then we will parse it, or we will traverse it, and by traversing, we will, whenever the production is completed, we will print these commands. So S of AAB, so I can make it by S to AA, then again A will go to SB, and then again S will go to A. So whenever I traverse it, S of A is completed first. So when S of A is completed, 2 will be printed. When A of SB is completed here, at this point, A of SB is completed. So 3 is printed, and at the end, S of AA will be completed. So 2, 3, 1 will be our output. So option C will be the correct answer. Next is, it is saying for input 1 into 7 plus 9, what will be printed? So 1 into 7 plus 9, what will be printed? So let's see. 1 into 7 plus 9. How can we make 1 into 7 plus 9? So for first A, from A we will go to, from A we will go to BC. Now B can make, now C can make multiply, and B can make ID also. B to D, D to ID. So what we can do, B to D, D to ID, B to D, C to, D to ID. After that, C will give us star B, and then we are having C. Sorry, we are having C again. Now this B will again go to D, and this will, we can send this to C is going to B, C is again going to star B, C. Yes, okay. B, from B we can go to D plus B, and after that D will go to ID, and B will go to D, D will go to, there is an issue with the space here, so just manage it, this, and this C will go to epsilon. Now this is a tree. This ID will give you 1, this ID will give you 7, and this ID will give you 9. So we are making 1 star 7 plus 9. Now we have to parse it. Now whenever we parse it, so whenever D to ID is completed, we print the ID value. So D to ID is completed here. So we will print the ID value, which is 1. After that, we go back and then we try to complete this one. And whenever, again, when we come down, D to ID is completed here. So 7 is printed. Again, we will go back, and when D to ID is again completed, we will print 9. Now you see, whenever B to D plus B is completed. Now B to D plus B is completed here. B to D plus B is completed here, and whenever B to D is completed, we will print plus, and after that C to star BC. Now in C to star BC, whenever star B is completed, after that we will print star, and then we will move towards C. So what we will print here? We will print star here, and after that we will go back, and then we will complete the tree, and then there are no more print options in it. So it will give you what? 179 plus star. So I'll provide the solution for this one in a more clear diagram, because there was some issue with the board here. So so the answer will be 179 plus star. So the correct option will be option D. Next is, consider the following SGT. S is equal to AB, and A is taking value from B. Now whenever A is taking value from B, this is taking value from its neighbor, or you can say its sibling. And whenever any attribute takes the value from its sibling, it is called inherited attribute. Now after, if it is inherited, it is not synthesized, it is what? Inherited. Now whenever it is inherited, for S attributed we require synthesized. For S attributed we require synthesized. For L, so it cannot be S attributed. Now for L attributed we can have synthesized or inherited. So it is having inherited attribute, so this can be L attributed, but there is a catch here. What is the catch here? In L attributed there is a condition. If you are taking from a sibling, you should take from left sibling only. So you can take from parent or you can take from left sibling, but here we are taking from the right sibling. So it is not it is not S attributed, and it is also not L attributed. So the correct option will be option D, which is none. Next is, consider the following SGT. Consider the following SGT. Why it is not rubbing? Okay, let's leave it. So consider the following SGT: E is equal to E plus T, E is equal to T, T is equal to T into F, T is equal to F, F is equal to ID, and the output of 2 plus 3 plus 4 is. So in order to make 2 plus 3 plus 4, we are making E plus T here, 2 plus 3 into 4. So T into F here, and when we are having F ID, and T F and ID, where these will be 2, 3 and 4. Now we will traverse this one. So 20, okay, someone is saying 20. Now whenever we traverse this one, when we complete F to ID, it is saying that give the number value to F. So F will get 2, Then t value will be given, f value will be given to t. So again it will get, t will also get 2 and e will also get 2. Till here we are good. Again f will get value 3, t will get value 3, 4, f will get value 4. Now whenever t equal to t into f is completed, it is saying t value plus f value. Now the symbol here used is into, but the operation we are using here is plus. So we will plus these two and put the value to t, which is upper t 7. And whenever we complete e is equal to e plus t, it is saying multiply the value of e and multiply the value of t. So it will give you answer what? 14. So you have to keep in mind, they can give any symbol here, but you have to perform the operation which is given in the syntax directed tree. So this is the STD and this is the operation that we are doing. So this operation says plus for star and multiply for plus. So the correct option will be option A, which is 14. Next is consider the following grammar. This, what will be the follow of B? Now what is the follow of B? Now how can we calculate the follow of B here? First of all, check the right hand side where B is present. So after B there is nothing. So for follow of B we need to find follow of S and we need to find follow of A. Now S, when you try to find the follow of S, S is not present on the right side of the system. So it is just a starting symbol. So follow of S will be nothing but dollar. So dollar will be the follow of S. After that, when you try to find follow of A, this A will give you again, you will go back to follow of S. So it is a loop, infinite loop. Again for this A, you will again go back to follow of B, which we are trying to find initially. So it will again, it is an infinite loop. A will go to B, B will go to A, and they will keep on doing this. So there is only one symbol for this, which is option A. Dollar is the follow of B. Next is for this language, what will be the follow? So for this language, what will be the follow? Yes, now it is gone. Now see here, it is saying first of E union follow of E dash. First of E we can find, first of E will be equal to first of T. From here we can find first of T as first of F, and first of F is nothing but bracket and ID. So the font is little smaller, bracket and ID. So this is the first of E union with follow of E dash. Now how to find follow of E dash here? Now follow of E dash will be nothing but try to find E dash at the right side. So there is only one E dash, two E dash on the right side. So they are at the end. So we will go back and we will go back to again E dash will go back to E dash. So it is just an infinite loop follow of E dash. Now this follow of E dash will go to, we need to find follow of E. Follow of E, where E is on the right side? E is on the right side here. So follow of E will be first of the next item. Next item is what? Nothing but a bracket, and also E is the starting symbol. So follow of E will be your dollar also. So when you do the union of this, it will be two brackets ID and dollar. Two brackets ID and dollar. So the correct option will be option number C. Next is this is the you have been given a SDT and it is saying what will be the output if you print BS. So we have tried this similar question before. 231 was the answer. It is the same question. I get it. It is repeated here. After that, 44 is saying that you have been given three conditions. Upper arrow is higher precedence than lower arrow. Upper arrow is right associative and lower arrow is left associative, and it is saying what will be the parse tree of this following expression. Now see how to handle these questions. What we can do here is A, B, sorry, we have a down arrow here. then we have B, then we have C, then we have D, and then we have F here. Now this is the expression that has been given to us. Now higher precedence is for upper one. Now upper one will be done before. One more thing, upper one is right associative. So if there are two upper arrows on the same expression, right one will be done first. So the first priority will be given to this. Then we will solve this second one. Now after solving this, these two are lower arrows, and lower arrow is what? Left associative. So this will be done first. So I will change the color here so you can understand it much clearer. So we will do this one third, and after that the last one will be done at the fourth place. So now when you make a tree which is having a higher priority will be done at the last level, and which is having the lower priority will be done at the top level, because we go from top to bottom. So we will go in the reverse order. So the first is, so the last we did this one. So if we do doing this last, so F will come here and there will be a tree here. Then after that, second last we are doing this one. So again, lower arrow and left side we will be having this. After that, second number we are doing this one. So upper arrow, B on this side, and on this side we will be having C and D. So C and D will be solved like this. So this will be the tree. So the correct option will be option A for this one. Now next is, let's move on to the next question, 45th question. Consider a following grammar. I will write the grammar down here. Consider the following grammar. So the one that is missing is A. A is equal to BB BB slash bigger C and CB, and it is asking that what will be the follow of B and first of A. Now if you see follow of B, B comes at two places. So from this B, there is nothing in after that B. So we will just go back, and it is an infinite loop. First of follow of B will be again follow of B. If you see this B, B is on the right side. So the follow of B will be first of this one, which is B. And you take its intersection with first of A. Now if you take first of A, you will get B. First of B will be equal to A and epsilon. So epsilon cannot come in first of anything. So we will put this epsilon here, and then first of B will become B. And again, using this production, first of A will be equal to first of C, and first of C will give you smaller c, and this C, whenever you put this C as epsilon, when you go back, it again gives you first of A as B. So the three options follow. First of A will be ABC. Follow of B will be B. If you take the intersection, you will get B here. First of A will be first of BB and first of CB. First of B will give you A, and whenever you put epsilon here, it will go back, you will put epsilon and it will give you B. For this, if it will give you C, and epsilon, when you put it back, it will again give you B. So ABC will be the first of A, follow of B will be B only. Now next is 46th question. It is saying follow of E in this grammar. Now follow of E. First of all, E is the starting symbol. So dollar will be the follow of E. One thing is here. Next is follow of E will give you at and the right side follow of E is here. So it will give you, so you have to find follow of A also. Now we will see where A comes in this. So for this A, follow of A will be first of bracket. Next, for this A, if you take the first A in A production goes to double A, it will be follow of A will be equal to first of next symbol. First of next symbol is what? First of A. Now we have to find the first of A. First of A is nothing but first of A and then first of E. First of E is nothing but, so from here you are going to first of A. First of A gives you first of E, and first of E is nothing but this bracket. So previously bracket was this one. So this bracket and the number, and after that the next A it will again go back to follow of A, and then it will start the infinite loop. So the follow of E will be number, dollar and two brackets. So number, dollar and two brackets. So the correct option will be option B. Any doubts in this till now? Next is 47th C part. Sorry, whatever the question is. So S is equal to S1, S2, C, S is equal to A, S is equal to B. So what will be the input for B, A, B, C, C? What will be the output for this input? So let's make first the tree. S is equal to S, S, C. So we have made this C, and again for this S we will again go to S, S, C. For this S we will go to B. For this S we will go to A. For this S we will go to B again. And then we will try to parse it. Whenever we parse it and whenever S to B is completed, it is saying that S will be, value will be moved to 6. Again we come back, S value is changed to, when S of A is completed, S value is changed to 2. Whenever we complete S to B, again value is changed to 6. And whenever we complete S to SSC, it is saying that S1T minus S2T, the value of S1 minus value of S2. So value of S1 is 2, value of S2 is 6. So 2 minus 6 will give us minus 4. And then again we will go and traverse it, and whenever we complete the production of S is equal to SSC, again S1 minus S2. 6 minus minus 4, it will be equal to 10. So the correct option will be 10. 6 minus 4, 6 minus minus 4 will be equal to 10. So the correct option will be option number A. Next is 48. It is saying, it is asking about the presidents. Now these are at the top level. So this will be having least presidents. So star and plus will be having equal presidents, and minus will be having greater presidents than both of these symbols. So the first option is star has higher presidents than plus. No, star and plus has equal presidents. Minus has higher presidents than star. Yes, this is true. Plus and minus are having same presidents. No, minus is having more presidents. Plus has higher presidents than star. Again, not true, because plus is having equal presidents than equal to star. So the correct option will be option B, which is minus is having higher president than star. Next is 49th question. So there is some issue with this typing issue with this one. So I will write the correct thing. So S is equal to AS, and we will print 1 here, and again S goes to AB, and we print 3 here. And then for DB the print is 2, and there is one more production, B is equal to BC, which will print 3. So it is saying for input AAA DBC, what will be the output? So we have to again make a tree for it. So first of all, S will make AS, and this production is A. Again, one more change. This is A to A. So we will make S to AS, again S to AS. Then this S will be changed to AB, so that we can make 3 A's from the A. And whenever we have made 3 A's, after that we need D. So B can make DB. After that B can make BC. So this is a tree for AAA DBC. Now whenever you complete this, traverse this one, A to A will give you print of 2. Whenever A to A is completed, it will give print as 2. Again A to A is completed and again A to A is completed. So 2 more 2s here. So triple 2 comes. After that, whenever B to BC is completed, so whenever B to BC is completed, it will print 3 here. After that, we will complete B to DB. When B to DB is completed, 2 will be printed. After that, S is equal to AB is completed. Whenever S is equal to AB is completed, 3 is printed. After that, S is equal to AS is completed and printed will be 1 will be printed. After that, S to AS is again printed and 1 will be printed. So the correct output will be 22232 So A option will be our correct option. Now the last question is, consider the following expression. We have to make the DAG for it, DAG for this one. So it is not rubbing, so let's ignore it. So we have to make a DAG for, so this is the last page, I guess, so that is why it is not moving. So we have to make the DAG for A plus A plus A plus A plus A. Now what we do sometimes, what mistake we do is, we will make, let's say, A plus A plus A plus 4 A's we have to make. So what we will do, so A will take value from plus, A will take value from plus, so it will make A plus A. And what we will do again, we will take this value. So this is giving us A plus A. So this will give us A plus A plus A plus A. So this DAG is true for what? If the case is this, if you have been given some brackets, then it is okay to use this A plus A here also, because the left side will give you again A plus A, right side will give you again A plus A, and then you will be able to use this DAG. But not in this case. You have not been given any brackets for it. So what we will be doing, so plus is what? Plus is left associative. It always takes the values from left. So first we will make 2 A's by what? By doing this. So we have made these two. Now when we have to add this A plus A to one more A. We will not take another two more A's because we are going one by one. There is no bracket here. So we will take A plus A we will take from this side, and 1A we will take from this side. So 3 A's we have covered. 4th A again we will cover like this only, that we will take 3 A's from this side and 4th A from this side, and 5th A again we will do like this, that we will take 4 A's from this, 5th A from this, and after that at the end equal X. So we will take equal 5 A's we will take from this side and X we will take from this side. So this is the DAG. This will not be the DAG for this, because here you are using A plus A, then you are taking A plus A, then you are taking A plus A. But it is not given. Brackets are not given here. What it is given? First you will solve 2 A's, then it will see that one more A is there. So it will add 1 A to the 2 A's. Then after doing 3 A's, it will see that there is one more A. Then it will again add one more A and again one more A, and after that you will solve it. If there were brackets here, like this one, then you would have A plus A, you would have made A plus A and used that A plus A again like this one. So the DAG would have been smaller. So the correct option will be option C. So these are the 50 questions that we have done today for theory of competition and compiler. Both are very important subjects and both are very scoring subjects. So I hope you understood all the concepts that we have discussed today. If you have any doubts, you can put it in the comments. I will surely try to help you out with your doubts. So for today, this is all. Next session will be on I have shown you earlier also what was the list of all the sessions that we will be conducting in this month. So keep watching and keep following YourPedia for more videos, and try you can also try the questions from our NIC book that we have launched recently. It is having 2500 plus questions on these topics, and the difficulty level of those questions is also at par with these exams. The questions are not that easy. The questions are not that difficult. It will be at par with these questions that are asked in the exams such as NIC, ISRO, or UGC NET, these type of exams. So I hope you liked this video. I hope you understood all the concepts. So keep sharing and keep preparing. So thank you and good evening.